The optimal solution, duplicate integer leak code, is by checking as you go, and then we would short circuit the moment we would with a function and with the class find the has. So from here we would begin with seen as a set for nums and num. If num is seen, dot add. Disregard the errors for the moment, but this is the most optimal have. And the reason why is because this is early term. So the best case is O1 if first two elements match. And it's the same worst O(n) time, O(n) space. The crucial takeaway is that when we're in this for loop, for num and nums, and we're getting the integer value, if the num isn't seen, if the integer value is in the set, we would so this means that if we have values that are in this set, we know that it would be a duplicate. Because if there's no numbers, if this set is you're adding stuff, this condition initially was false for the first condition, and then you would add that set right here. You would add the nums, this, you would add the values of the nums, this set right here, and then we would iterate again. And if nums isn't seen, then would return true. If it goes through the entire for loop and it doesn't find any duplicate, then it would return false. Let's do a quick little demonstration and consider values inside the list 1, 2, 3. So right here, 1 will pass in this for loop. For num in nums, 1 would go in. If 1 is seen, return true. But it's not, so we would add 1 to the set seen, and we would go through the second iteration with for num and nums, so the num in this case, if 2 is seen, return true, but it's not, so we would add that right here. Now here comes the third iteration. If num is seen, so we know that 2 right here, the 2 is seen since we already had 2 inside the set, and you know that the sets cannot have duplicates, we would return true. And as you can see, this code short circuits the moment, even though 1 is a duplicate, we would not even consider this, and it would